Hi there. This day has totally gotten away from me. It's already dark, but I did say I was going to talk about chaos theory, so here I am. And this is going to be more than 3 minutes, so I'm going to put this on my YouTube channel, and then you can follow a link and get it there. The reason it's important to talk about chaos theory is because of these charts that we use, and this is why it comes up. The link to the ECMWF, the European Centre for Medium Range Weather Forecasting, run what's called an ensemble forecast. So they run the same model 51 times. And the reason they do that is because every time they run the model, they change something in the starting conditions, in the initial conditions. So you'll have heard of the chaos theory, I'm sure. A butterfly flaps its wings in the Philippines and it causes a hurricane in the Caribbean. Now, one thing doesn't cause another, but what we're talking about is small perturbations, small changes in the atmosphere causing big changes further down the line. That's what we're talking about when we talk about chaos theory, and in particular, small changes in the initial conditions. Now, I do lots of talks. Today I talked at a school, and last week I talked at a yacht club, and next month I'll be talking at a retirement club. And I like to talk about the weather, the science, how it all comes together. And I remember somebody, when I was asked to write my book, they say you should, my first book, The Great Irish Weather Book, when you should write a book when you can't not write a book. So when I started to write the book, I was like, where do you begin? Where do you begin with the weather? Well, you begin with the sun. The sun is the source of our energy. It's the source of our heat. It sends radiation through the universe to the earth, and it heats the earth. The earth is not heated evenly. If it was heated evenly, we wouldn't have quite so much to work with. It's not heated evenly, and this is where the variability begins. Actually, it begins with the sun, because the sun is not a constant. It's variable. There are heat spots, and the actual radiation varies. When it gets through the atmosphere, it varies again, because the atmosphere is different depths. At the poles and at the equator, the atmosphere is a different depth. The angle of the radiation affects how much radiation is getting through. The surface of the earth depends how much radiation is reflected away. Are there clouds? Is there snow? The surface of the earth itself, is it sand? Is it water? Is it forest? So the absorption of the heat, the way the earth is heated, is uneven distribution of heat. That's what causes all the problems. The same as in the world's politics, the uneven distribution of wealth. That's what causes all the wars, the uneven distribution of wealth. Well, what causes weather is the uneven distribution of heat. And of course, the world is spinning. So we've got rising air. The Hadley cell, as somebody commented in one of mine, the rising air at the tropics and falling at the poles and moving around, and the earth is moving and the air is rising. All of these variabilities all have to be taken into account when we're trying to construct a weather forecast. A colleague of mine did this example years ago, which I thought was very useful. Picture yourself standing on the top of a hill. And now I like to picture myself standing on the top of the hill of Tara, even though I haven't been there in years. Stand on the top of the hill and make a snowball. Nice compact snow. And drop the snowball down the side of the hill. And you can picture how that snowball will get to the end of the hill, what it will look like. It will gather snow as it moves down the hill. Now, rewind and do exactly the same thing again. Make your snowball at the top of a pristine hill, at the top of the hill of Tara. Drop your snowball. You'll notice it doesn't go exactly where it went before, and it doesn't have exactly the same construction when it gets to the end of the hill. Even though you did the same thing, you made the snowball and you dropped it from the same place, there are subtle variations that make an impact further down the hill. So when we're making a weather forecast, there are huge amount of variabilities, subtle variations that can go not wrong, but different when you're measuring the atmosphere across the whole globe and through the depth of the atmosphere. And you're accounting for all of the changes that can be accounted for. your starting conditions. You've taken a snapshot of this atmosphere as best you can. You can't measure every square inch of the atmosphere, but you've taken as good a snapshot of the atmosphere from your starting condition, and you've run with that. You make a little change and you run with it again. You make a little change and you run with it again. And the ECMWF do that 51 times. One control run and 50 other varied runs in order to create an ensemble forecast that gives us an understanding of the possible outcomes in your forecast as you go. And you'll notice as well, on day one, almost all of the 50 members of the ensemble will look nearly exactly the same. As you go further along the line, as you get further away from that butterfly in the Philippines, across the Atlantic to the Caribbean, you'll have further, bigger implications. So the forecast gets less certain, not less reliable, less certain as it goes further from your starting conditions. That's my explanation of chaos theory. That's my explanation as to why we use the ensemble forecast and how to understand that the initial conditions, the initial changes can have impacts further along and the variations further along. I hope you found that helpful. And, subscribe and follow for more and all that sort of stuff. I'll hopefully have more explanations coming up over the next while. Danke.